video, we're going to very quickly go through the difference between Pearson's correlation coefficient and Spearman's correlation coefficient. Now, we've seen Pearson's before in chapter 2, also called PMCC, and it takes the range of values from -1 to 1. And if the value is close to -1, this means that we have a correlation which is strong and decreasing, like that. If our value is close to 0, it means we don't have correlation. A set of values like that could look like x squared type distribution. It could look like a uniform distribution, or it could just look completely random. And when r was 1, it looked like that. A strong correlation that is increasing linearly. Okay. But problems start to arise in Pearson's correlation coefficient when dealing with nonlinear data. So if, for example, my data set looked like that, kind of like an exponential function, would we say this has strong correlation? Well, yes. It does have a strong correlation, but it does not have a strong linear correlation. So for a calculation like this, r would not be as close to 1 as we would expect it to be. However, what Spearman's correlation coefficient does is it ranks the data. So it will say, okay, the highest data point is 1. The second data point is 2, etc. And it'll rank all the data. I have too many points here, but it'll rank all the data. Let's say there are 10 data points. So it ranks them in order from 1 to 10. Okay. Now, if I were to replot that graph with just the ranks, I would get a linear correlation. So the only difference between Spearman's and Pearson's is instead of doing the PMCC calculation, which we do on our calculators, right? Spreadsheets and then put the data in 2 variable statistics and we get y. Instead of doing on this, I first rank my data and then I do the same calculation with this data set. So some of the benefits of Spearman's is it works on data which is not linear. You can kind of think of it as linearizing the data and then doing PMCC on it. And also, it is not as susceptible to outliers. So, for example, if I had a data point that was like way up there, really it's high, completely off the scale, way up in the sky. If I rank it, it would just be, the 11th data point. So it wouldn't be as susceptible. And over here, we'll do a little example. So here's the data set. The x values are given, the y values are given. And what I would do to calculate PMCC is just do our calculation by putting this data into spreadsheets on our GBC. But to do Spearman's calculation, I rank the data first. So I say, okay, what's my highest value for x? Highest value, I'll give it a 1, it's 45. Next highest value is 34, give that a 2. Next highest value is 29, call it 3. Next highest value is 23. The fourth highest value is 23. But also, the fifth highest value is 23. So we call it 4.5 and 4.5. And then the sixth highest value is 17. I do the same for y. And then I do the exact same calculation as I would have done for PMCC. The exact same calculation. You put this data into your spreadsheets on GBC, menu, stat calculations, 2 variable statistics, and you will get y. That's it.